So in this example here, we have two wires. They are carry the current in the two opposite directions, 5 amps, and we need to find the directions and the magnitude of magnetic field at the certain point. In this case, it is B, located a certain distance from the two wires. And here, since we know the formula to find the magnetic field around the wires. Now, the only thing is here, we have two magnetic field comes from the wire number 1 and wire number 2. So since the magnetic field is directions, it is the same thing that we deal with the electrical field before. So we just add that point and find all the component from the each magnetic field, and then we add it as a vector. So we add the Y component and X component together, then we find the magnitude engine. So to make it, this one is easy to observe. So we're gonna use the right-hand rules to find the direction of magnetic field at this direction. So at this point, all the directions, they be the same for the wire 1 and for the wire 2, according for the direction of the P. Okay. So to make it easy, I can make another observation for this one by rotating those two wire 90 degrees. So by rotating this wire 90 degrees, so the I1, it will be toward inside the page, and the I2, or the current from the wire 2, will be go outside from the page. And here is my point P at that distance. So from here, if I apply my right-hand rules, so I can find the direction of the magnetic field. In this case, right hand, your thumb is going to be inside the page, and your curl finger will be toward this direction. So this direction of B1. Similarly, if I apply the rule, the right hand rules in the second one, whereas your thumb will be out and your curl finger will be toward the magnetic field, I will find the magnetic field directions will be toward left side. And here is the B2. Now, the only thing here you have to be careful with that. What about the magnitude? Which one will be going to be larger? I have only component in X direction. So this is my X directions here. I don't have any component in Y direction. So what the magnitude is large, so that's the direction of the total magnetic field. So since this one is the closest, the I1, let's call this one is 1, and this one is 2. And the magnetic field that from the I1 will be larger than I2. So the total magnetic field will be on the right side. So let's find the magnitude. Since we find the direction, let's find the magnitude for both wires. So here is the B1. We need a formula. Here is the mu times I. 2 by R. Let's call it R1 and I1, just to indicate it to the talking about. Here is the I1. And here is the, if you want to take it, the R1 plus R2. So the R2 will be this R2. You want to be accurate, this is one will be R2. Here is the numerical value that we have. Here is 1.26 power to the minus 6 unit Tesla meter divided by amps times 5 amps divided by 2 by R.08 meters. And in this calculations here will be 1.253, sorry, 1.253 times minus 5. Tesla. Now let's try to find the P2 in that case. P2 has the same formula. Here is the mu, 0, I2 divided by 2 by R, R2, let's call it. So in this case, here is the R1, 2.08, and R2 double. So basically, then the I1 equal I2 So here is the equal I1. And what about the R2? R2 basically it is just 2 times R1. So here is the 2 R1 as the current. So from that relation, so if you're comparing those, if you're comparing this one is that going to be 2 R1. So from here, I can find it easily. It's just a half of P1, which basically it is just 0.6 to 7 power to the minus 5 Tesla. You can plug your numbers here as we did here. The only difference will be 0.016. So the double of that case, so reduce the magnetic field to the half. So from that case, I wanted to find the magnetic field as a magnitude in general, P total. Both components they are in the x directions. I have only component in one direction, x direction. If the case is different, that is different. But in this case, x, just in one directions. What the first case here? So you end up B1 and B2, just half will be end up with the 0.627, okay? 0.627 power to the minus 5 Tesla. What regarding for the directions, we know the direction is the same direction of the P1. What is the P1 resulting from the I1 in the current I1? So if you want to refer it to your original case, you will say this one is here because the magnetic field here, right hand will be this case. It's the magnetic field. So the same direction is here. So we can say this one into the page. Into the page. So that's the first example. So now let's move on another topic, which in this case, regarding for the charge, this one is section 24.5, when I have a charge moving in magnetic field. Okay. When we have a charge moving in magnetic field, that will create a force. So let's see, here's we have an example here. I have the simulation to observe that effect. Let's run the simulation very quickly and see what happened. We have here the 3 charges with the magnetic field point inside the page. And we have positive charge, negative charge, and no charge in that one. Apply the magnetic field, they have certain velocity. They are all of them pointed up. When they are starting moving magnetic field, I see there is the 2 different movement. So no charging particles will be no change in their velocity and the directions. But for the positive and negative particles, they will be turning in 2 different directions. That turn means there is a force or the magnetic force let that happen. So now let's go back for our PowerPoint. Let's confirm what do we have. So for now, since those I have 3 components, I have particle moving with a certain velocity, I have magnetic field, and I have what I observed from the simulations magnetic force. So those are 3 components. They were gonna to find the directions, and next lecture we're gonna how to find the magnitude. But in this one we're gonna focus about the direction of that force. We're gonna use another right-hand rules. Where is that? That right-hand rules based in the 3 fingers. Based in your thumb, which all the time indicated to the direction of the velocity. Your 4 fingers will be toward in the magnetic field directions, and your middle finger toward the magnetic force. Let's apply some examples here and see how we're gonna apply this concept. So the first one here, I have magnetic field pointed up, and I have velocity for the vertical velocity going to the right side. and ask what the magnitude, what the directions. We are just focused about the direction right now. What the direction of magnetic force. So let's just give you a minute to think about it, or they can pause the video to try to observe by your own. Right hand, your thumb will be toward your velocity, and your forefinger will be toward the magnetic field, and your middle finger to point it to a force. So here is the right hand. If you're gonna apply it in that case, velocity, thumb, my four fingers will be go up to the magnetic field. Now I end up with my fingers pointed toward or the out of the page. So that's the direction of magnetic field. So we can call this one magnetic force is out of the page. Let's apply another example for that. Let's see this example here. What do we have? We have the positive particles, and we have certain velocity go to the right, and we have the magnetic field pointed inside the page. And we need to identify the magnetic force directions using right hand. It is not silly, but you have to practice it because you cannot imagine it to find the directions. So the right hand rules, it is easy way to find the direction of magnetic field, since we are dealing with the 3 dimension. So in this example here, we need a little bit of a trick, and you need to twist your hand a little bit to find that positions. Where is your right hand, or your fingers, and your forefinger toward inside. So you need to twist your hand a little bit, and if you twist that case, you will find the direction of the force will be toward it up. Okay. Toward it up, based in the right hand rules. Now let's see the second example here, and the last one here in this follow the page. And here's we have the positive particles, and it has a certain velocity with the directions up, and I have a magnetic field toward up as well. Now, if you try to apply your right hand rules, you have a difficulty to find those cases. So how you can find your or how you pointed your thumb and your forefinger in the same direction. But we have something, it is to make this situations easy. And that the rules is, if my velocity v and my p, or my magnetic field, they are in the same directions, then the magnetic force is finished. So which means there is no magnetic force. So as a result, the magnetic force will be 0 if I have velocity and magnetic field pointed at the same direction. Okay, so now let's apply or define the last case. If I have a magnetic field and I have the velocity and they have certain angle with that. In certain angle with that, we're gonna apply the magnetic field. In that way, in this particular example here, since my velocity is certain angles, we know the velocity is a vector, so I can analyze it to the 2 components, where is the y component and x component. And from the previous rules, so the y component will be toward the same direction of magnetic field. So there is no magnetic force in this component. So basically what we end up, I have the only component or x component directions here. So I have to put my thumb to the word velocity will be toward right side, and my magnetic field point up, the 4 fingers point up. Then I can find out my force will be toward outside. That outside. Out the page. Now the only thing here in this the right hand rules, we basically find the directions. So here when we find the components, the directions, so we're gonna learning how to find the magnitude. So this one we need this formula when we need to find the magnitude of that force. But as a directions, I know the direction it should be in the right side direction. So the right hand rules basically provide me the easy rule to identify the directions based in the vertical movement or motions and magnetic field in it. Thank you so much. So next lecture, we're going to start to dealing with the find the magnitude of the magnetic force.